Hey everybody, welcome back to more college algebra, and this is section 2.2, which is more on functions and their graphs. And so we've talked about some basics of functions already. Today in this section we have a whole lot to cover. Now in your textbook there are 6 concepts that the textbook covers. We're only going to cover 4 of those, and so these 4 we're going to take a look at increasing, decreasing intervals for a function. We're going to look at tests for symmetry and what an even or an odd function means, and then we're going to look at the basics of difference quotients. And so lots of stuff here. For those of you that are going to go on to calculus, you will see all of this stuff pop up in there, and so it'll be a little while before you see that, but this is some good information. This video is going to be a little bit longer than some of the other ones, so just bear with us and do your best to keep up. If you need to watch it in 2 shifts or something, then do that. But there's a lot of good information in here. Okay, so increasing. A function is increasing on an open interval whenever f of x1 is less than x2 for x1 less than x2. And so in other words, when the x's are growing, the y's are growing. All right, so what does that mean on a graph? That means you're going up from left to right. That's increasing. Okay, a function is decreasing on an open interval if f of x1 is bigger than f of x2 whenever x1 is less than x2. So as x1 gets bigger, as the x's increase, the y's decrease, hence decreasing, and that means it's looking something like this. That's what decreasing means. And then constant just means that the y values aren't changing even though the x values are changing. The y values are staying the same, so that's constant. And graphically, a constant function looks like what? It looks like a flat line, horizontal line. All right, horizontal line is a constant function. Okay, so let's take a look at this example. All right, we want to show where you're increasing, where you're decreasing for this particular function. And so what we're going to do is we're going to work at each spot. So basically this arrow means forever, right? Goes down forever. And so as we move left to right, what's happening to our function? Our function's going up, 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 up. This is increasing the whole time, all the way till right here. Okay, and so from forever this way all the way up until that point right there at x equal -1, we're increasing. So we would write that we are increasing on -infinity to -1. As x moves from left to right, the y values are going up, up, up until you hit -1. Now what happens at -1? At -1 you start to go back down. At -1 you start to go back down, you're going down slowly, and then it looks like you kind of bottom out here at +1. And so what that means is that you are decreasing between -1 and 1, and then what happens after 1? After 1 you take off again, you start going up again, and so you're increasing on 1 to infinity. Okay, and so you have that's the layout. It wasn't constant anywhere. That's the only thing we were missing, and that's kind of how you play it out. I will never give you points that are weird, right? If it looks like it stops going up at -1, it is -1. It's not -1.2 or something weird like that. All right, I'll be nice to you. It's pretty simple stuff. Read it right off the graph. Okay? So next, we're going to talk about even and odd functions. An even function is defined to be a function in which if you plug in -x and x to the function, you get the same number. For every single thing, all the domain values. So not just for one of them. So f of -1 equals f of 1, f of -2 equals f of 2, f of -7 equals f of 7, or for whatever's in the domain, right? And that's true for fractions too, or whatever's in the domain, all right? An odd function means that when you plug in -x, you get out -y. So f of -1 is equal to the opposite, negative of f of 1. And f of -3 is equal to the negative of f of 3, that kind of thing, okay? So examples of this, some real simple examples of this, all right? An example of an even function is f of x equals x squared, right? If you plug in negative numbers or positive numbers, you get the same thing out. Negative 2 squared is 4, positive 2 squared is 4, that kind of thing. All right, and then f of x equal to x cubed, that's a great example of an odd function, because if you plug in 2, you get 8, but if you plug in negative 2, you get negative 8. You get the opposite, right? And so that's just the simplest way to describe what even and odd functions look like. Now, how do you test for them? How do you do it algebraically? Well, let's take a look at that, okay? So we want to see if this function, h of x equal to x to the 5th plus 1 is even, odd, or neither. Well, how do we test for even? Even is h of minus x has to be h of x. So if you plug in h of minus x, you get negative x to the 5th plus 1, which is negative x to the 5th plus 1, because a negative raised to 5 power is a negative, right? And that is not equal to x to the 5th plus 1, right? So that's not even. Well, how do we test odd? You test odd. Odd is what? So this was for even. What's odd? Odd is h of minus x. And again, you get the same thing when you plug it in. You get negative x to the 5th plus 1. Is that equal to the opposite of x to the 5th plus 1? Well, no, it's not, because if you factor the negative out here, you get negative x to the 5th minus 1, which is not the same as this, and so it's also not odd. Well, so what does that mean? That means it's neither. Neither h is neither odd nor even. It's neither one of those, and functions are not numbers, right? So integers have to be either even or odd. Functions don't have to be. Some can be even, some can be odd. A couple are actually both. All right, we're not going to worry about that right now, but and then there's a lot of functions that are neither one, and so neither is not a big deal. If you find that they're neither, that's the way it goes. All right, so like we've been doing here, here's a second example. I'd like you to pause right now and you try this on your own to determine if the function is even or odd or neither. And again, you're going to test each of those because you have to test even and odd both, because it is possible to have a function that is both. All right. And so you have to test both of them every single time we ask you. All right, so hit pause and then come back and see how you did. All right, so we're going to test for even. Plug in minus x. What do you get? You get 2 times minus x cubed minus 5 times minus x, which is 2 times minus x cubed plus 5x. You get negative 2x cubed plus 5x, and that's certainly not the same as the original function, so it's not even. So now test odd. You do the same thing, plug in f of minus x. What did we get? We got negative 2x cubed plus 5x, but guess what? That is the opposite of 2x cubed minus 5x. See, all the signs are exactly the opposite. And so that's true, so this is an odd function. And so it's not even, but it is odd, and again, you have to test for both. And so in this case, we have an odd function. Notice that the power here is 3, and this power is what, 1? Both of those powers are odd. That is a way to tell, but you've got to identify, and so it's not enough to just look at the powers and be like, it's odd. You have to show me. You got to show me the algebra, okay? All righty. So what is left with that? We've got the difference quotient. Okay, the difference quotient is f of x plus h minus f of x over h, and that's used in calculus a lot. It's basically just the average rate of change formula, right? If x plus h is one of my x's and x is my other x, then if you do change in y over change in x, the x's cancel, right? And so this is just the slope of a straight line, or the average rate of change, or whatever else you might call it. All right, so let's work a problem together. Simplify the difference quotient. I will always give you this information. You don't have to memorize it. Okay? And so I'll give you this. And so if we plug in f of x plus h, this is the hardest part for students, and so I often do this by itself. How does f of x work? F of blank equals 4 minus 7 to the times blank, right? So if I put in 2 here, I'd plug a 2 in there, right? Or if I plugged in a negative 6 here, I'd do what? I plug in a negative 6 right there, right? Well, what are we plugging in here? We're plugging in x plus h. So how are we going to do that? We're going to say, well, we get 4 minus 7 times the blank. The blank is the x plus h. Okay? So if I simplify this out, distribute the negative 7, I get negative 7x minus 7h. So I'm going to plug that into my formula here. 4 minus 7x minus 7h minus 4 minus 7x. Make sure you're grouping things properly, all over h. Distribute the negative sign. I get 4 minus 7x minus 7h minus 4 plus 7h, all over h. If I've done this correctly, I'll have 4 minus 4. I'll have negative 7x plus 7x. I'll be left with negative 7h over h. And now I can divide away the h as h divides h and leaves a 1. And so that leaves me with an answer of negative 7. And that is the difference quotient completely simplified all the way down as simple as possible. It won't always go down to a constant number. It won't always go down to negative 7. But if you do this correctly, the h in the denominator will always divide away. Always. Okay? So again, here's the second problem, a little bit more complicated. I'll write out the difference quotient formula for you. And again, I might suggest that you try to evaluate, f of x plus h by itself first, like step 1. Do this first and then come back to this formula or whatever. But go ahead and pause it, see if you can do that, and then come back and check your answer. Okay, so we've got negative 2 times, right? There's an x here and an x here, so 2 blank spots. F of blank equals negative 2 blank squared plus blank plus 5. So we get f of x plus h is negative 2 times x plus h all squared plus x plus h plus 5. If we simplify that, square out x plus h, you get x squared. You have to FOIL it. X squared plus 2xh plus h squared plus x plus h plus 5, and then distribute the negative 2 and get negative 2x squared minus 4xh minus 2h squared plus x plus h plus 5. And so if we go to this formula now, we get all of this. This is just f of x plus h, right? So we get f of x plus h, all this stuff, plus x plus h plus 5, and then we get minus the group f of x, which is just this, negative 2x squared plus x plus 5, all of that over h. All right, let's see what subtracts. Distribute the negative sign first. Distribute it. You get negative 2x squared minus 4xh minus 2h squared plus x plus h plus 5. Minus minus is plus 2x squared minus x minus 5. Again, the negative 2x squared and the positive 2x squared add up to be 0. X minus x is 0. 5 minus 5 is 0. And so you're left with negative 4xh minus 2h squared plus h. If you've done it right, everybody has an h in it. What does that mean? That means it's a common factor. Pull out the greatest common factor of h and get negative 4x minus 2h plus 1. If you factor h out of h, you get 1. That's divided by h, and then h divides h and leaves a 1. And so you're left with a final answer of negative 4x minus 2h plus 1. That's your final answer. It's okay to have an h in your final answer. You're just not supposed to have an h in the denominator, or at least not a plain h in the denominator. Okay, so that's that. There's a lot of stuff in this section. Make sure you get in that My Math Lab and do that homework and get lots of practice. There's about 4 different worksheets for 2.2 for the different content things, even and odd functions, difference quotients. All of those are separate. And so do a lot of practice, guys. You're going to need it. There'll be 2 homework assignments on this thing as well in My Math Lab. Okay? Thanks. See ya.